Linear equations. So we've seen this title before. How do we know that it's a linear equation or not? And hopefully you're answering me saying that we know it's a linear equation when it's a degree 1 equation. And hopefully you know a degree 1 equation is an equation that the highest exponent that you see is 1. So the standard form of a linear equation is in this form here. ax plus by is equal to c. Now we've seen the standard form of a quadratic equation many of times. It's very similar to what we see here. Ax squared plus bx plus c is equal to 0. That's standard form of a quadratic equation. This is the first time that we've seen standard form of a linear equation. And again, we know that it's linear because it's degree 1, because we do not see any exponents higher than 1 in this equation. What we want to do is we want to be able to graph this equation. And we've done it before. Before we've done it by just plotting some points, and then we played connect the dots with our points on our graph. So let's go ahead and review it that way real quick. Now I can start it like this. 2x plus 3y is equal to 6. But when we were plotting points before, my suggestion to you was to solve for y. That's going to make the rest of this table to be filled out much easier. So let's go ahead and do that. To isolate my y variable, the first thing that we would do is subtract 2x from both sides. So that gives me 3y is equal to 6 minus 2x. Then to get rid of the 3 off of the y, we divide the whole side by 3. And so our y gives us 6 divided by 3, which is 2, minus 2 over 3, which gives us 2/3 x. So when we randomly pick our x variables, we're going to substitute that in for this equation here. That's going to give us the y value that relates to the x value with that here. So since our x value is multiplied by a fraction, the suggestion that I would give to you is to pick multiples of 3, so when you're plotting these points that you don't have to worry about fractions. So let's just do again a quick few examples. I'm going to start with 0 because 0 is always the easiest thing to work with. So that gives me y equals 2 minus 2/3 times 0. Anything times 0 cancels out, so that all cancels out there, leaving me with 2 for the number for y. That gives me the ordered pair of 0, 2. Now my multiple of 3, I'm going to pick a positive 3, and that gives me y is equal to 2 minus 2/3 times positive 3. So my 3 divided by 3 cancels out, leaving me with 2 minus 2, which simplifies to be 0. So my ordered pair is 3, 0. Let me pick a negative value as well. Let me pick a little bit bigger than just 3. So I'm going to pick negative 6. So y is equal to 2 minus 2/3 times negative 6. Well, 6 divided by 3 leaves me with a 2, but I have this negative times this negative, so that cancels out. So that leaves me with 2 plus 2 times 2 are 4, and that leaves me with a positive 6. So my point here is negative 6, positive 6. So let's go ahead and plot these points and see if that's enough. That's going to give us the graph of this equation. So my y-intercept is at 2. My x-intercept is at 3. And then I have another ordered pair of negative 6, positive 6. And that point is up here. All of these points are lined up, so that tells us that the graph of this is going to be a line, a straight line. So all degree 1, or all linear equations, are going to have a straight line graph. So every graph that we're going to create in this section of videos are always going to be straight lines. So let's talk about lines and what information we know about them. And the first thing that we need to discuss is slope. So I want you to take yourself out of the math class for a moment, and I want you to tell me, if you were not sitting here watching a math video and I used the word slope, what you would probably think of. And most of the time I get the answer of, you think of skiing, mountain skiing, skiing down the slope. And I think that is a perfect example for this, whether it's math related or not math related. Some of us are daredevils, and we like to ski down very steep slopes. So our mountain, one side of it at least, is going to look like this here. Others of us may not be such as daredevils, and we do not like to go down those steepest slopes, so we might want to go down very shallow slopes. So that gives us this right here. So both of these here are examples of mountains, and they are examples of slopes. Now, when we talk about slope, there's actually two different factors that weigh into figuring out whether it's a steep slope or a shallow slope. Okay? The factors that weigh in is we want to know how tall our mountain is, and that is calculated up by the rise of the mountain. And we want to know how long or how wide our mountain is, and that is calculated up by the run. And then we want to figure out how these two relate to each other. So the slope is defined by the rise over the run of each mountain. So our steep slope has a very tall rise and a very short run. Our shallow mountain over here on the right has a very short rise, but a very long run. So all slopes, whether it's math related or not math related, are calculated up by rise over run. And that is how we compute our slope formula. If we were given 2 points, so our generic points x1 and y1, and our second one x2 and y sub 2, and if we wanted to calculate up the slope between those 2 points, we would calculate them up by taking the rise and dividing it by the run. Now, this symbol here, this triangle, okay, that actually represents the change. So this means the change of our rise divided by the change of our run. And we calculate up the change by just subtracting them. So y2 minus y1 divided by x2 minus x1. Now this formula should be fairly easy to memorize because it rhymes. Slope is defined to be the rise, which are the y's, over the run, which is the x's. So again, one more time, slope is the rise or y's, again, both of those lines, divided by the x's. So again, this should be a very easy formula to have memorized. So let's do an example here. The first example is we want to figure out what the slope is passing through these two given points here. The first point is -3, -2. I'm going to label that as x1, y1. And the second point is 2, 5. I'm going to label that as x2, y2. But if you actually label these in reverse order, it will all work out to be the same. So our slope is defined to be rise, which is y, over run, which is x's. So my y2 value is 5 minus my y1 value is -2. Be very careful of the double negatives that we see there. The minus comes from the formula, and the second negative comes from my y variable. Over my run. So x2 is 2 minus my x1 is a -3. So again, be very careful of those double negatives there. On the top, that actually gives me 5 plus 2, which is 7, over 2 plus 3, which is 5. So my slope in this example is 7 over 5. So my rise is 7 units over my run, which is 5 units. Now, I can double check this by graphing this. So let me plot my 2 points here. My first one is -3, -2. My second one is 2, 5. So here's my 2 points. If I wanted to graph the line and figure out my slope, that means I would go up 7 units, and that means I would go over 5 units. So that's how this line would be figured out. Notice that my line is going up, or it's increasing from left to right. It is increasing from left to right because I have a positive slope. My second example is we want to figure out the slope that goes to the points of -5, half 0, and 1, -7. Go ahead and pause the video and see if you can figure out what the slope is on your own. Okay, so my formula is my y2 value of -7 minus my y1 value of 0 over my x2 value of 1 minus my x1 value of -5 half. So on the top, that simplifies to be -7. On the bottom, my negatives cancel out, and I need a common denominator to add these. Well, I can write 1 as 2 over 2. So my bottom is 2 halves plus 5 halves, and that gives me a 7 halves. Now this is not the most simplified version. This is a complex fraction, which means fractions inside fractions. If we want to simplify this farther, maybe we want to write both of them as fractions. So let me write the top one over 1. Then this is just a division problem. And we know how to divide fractions is, it's as easy as pi. We flip the second. So let me take the reciprocal of the second fraction. We flip the second and we multiply. Now before I actually do any multiplication, let me cancel some things out. I have 7 divided by 7, which cancels out. So my slope of this actually gives me -2 over 1, or that just simplifies as -2. So this is my most simplified answer of my slope. Let's see what that means if we were to graph this here. So my first one is an x-intercept of -5 halves 0. Well, if I wrote -5 halves as a mixed fraction, that would be -2.5. My second point is 1, -7. So my second ordered pair is here. So my line connecting these looks like this. Now I could do one big slope like I did in my last problem. But if I looked at this along the way, my slope of -2 means I would go down 2 units over 1 unit, and that would give me that. Down 2 units over 1, and if I would keep doing this, then that would leave me at the last place, or my point that I got down there. So my slope is down 2 units over 1 unit, and I keep doing that multiple and multiple times before I connect my 2 dots. Notice that this line is going down, or it's decreasing from left to right. And that is the case because my slope is negative. So if it's going down from left to right, it's because you have a negative slope. So this is where I'm going to stop this video. And in the next video, we're going to be talking about how do we graph lines without just having to plot numerous points.